certainly appreciate the introduction here, and I did add, yeah, we're going to focus a bit on the outlook, but I want to do more because, obviously weather has such an, as you mentioned, such a big impact on what we do, and if we want to know where we are, we need to look back and see where we've been. I know a lot of times we don't want to look back, certainly at a year like last year, and really kind of dive in, but we're going to today. And then we'll move that into what our current conditions are looking like, how the drought situation's changed over the course of the winter, what we're looking like heading into this upcoming spring season, and then take a look at really initial spring and summer forecasts as we move forward. And then time dependent, I might get into some of the longer term management decisions in terms of changes that impact your management decisions on a long term basis, kind of that long term outlook. But we'll see how much time we have left here at the end. I will pause for questions over, sort of three natural breaks here today, over those three broad topic areas. So if you have any questions, put them in the Q&A or chat, whatever what you were instructed to do, and we'll go ahead and answer those. So yeah, it's good to be back. It's good to be part of this Corn College and Soybean School this year. And about a year ago, this time, actually a year ago tonight or early tomorrow morning, um, we dealt with what was our first sort of big tornado outbreak of last year. And little did we know what was going to happen after that. But this was scenes from Molly Cairn Ag Center there in London, looking east from the west side entrance there. Early morning hours of February 28th last year, about 4:30, 5 o'clock in the morning, we had our first tornado outbreak. And it's not, unheard of to have tornadoes in February. Ohio has seen several of those, but the strength of this one was pretty significant. 130, 135 mile per hour winds across the Madison County Airport and then into Molly Cairn area. But just the fact that we had an EF2 tornado that struck early in the morning in February. It's not often that February gives us those conditions that come together for tornadoes. You need a warm surface, a lot of moisture in the atmosphere, some rotation with height, and to get those in the early morning hours of February is actually quite something. We dealt with a lot of damage across the region, and as I mentioned, we didn't know what was to come. But this was really the outcome of last year. We had over 1,800 reports of tornadoes all across the United States, and a lot of analyses of those are still underway to get that final number. But in Ohio, our confirmed amount is 74 tornadoes across the state. And this is a nice photo from Nick Dunn. He's the weather specialist at WHIO there, Channel 7 in Dayton. That just shows all the locations of those tornadoes and really quite a few across the central portion of the state, west central, central Ohio, and even north and northeast Ohio as well. So our previous record was 62 back in 1992, and this broke that record by quite a bit. Now, the chart that you see on the bottom, this is really the tornado numbers every year since 1950, according to the NOAA's storm database. And we always get these questions about tornadoes and trends. And trends are really difficult to analyze for tornadoes. One, they're really small. Two, we all have these things now, these phones. So every tornado across the country has a picture or a video of it, it seems. Even the one that we had a couple of days ago out in the middle of nowhere in South Dakota. By the way, South Dakota's first reported official tornado in the month of February, which really is going unrated because so little damage that it can't be fully assessed in terms of strength. But we have images of these tornadoes a lot more today than we did in the 1950s and 60s. And so there's an observational bias that skews that as well. Not to mention, we've increased our technology. Radar technology allows us today to pick up a lot of the weaker systems, the weaker tornadoes, EF1s, EF0s, with those weak winds, even 60, 65 miles per hour. And so we're recording more of those, and we see increasing trends in those weaker tornadoes. But if you look at EF2 through EF5, so 125, 120 miles an hour wind speeds plus, all of those trends across the country are actually decreasing. And so it's a bit of a muddled sort of argument there. So we thought that this was going to be what we talked about last year at Farm Science Review, and that would have been plenty to talk about. But of course, conditions rapidly changed as we went through the spring. Relatively speaking, we had a wet spring for much of the state. In particular, there was some delays there across northwestern Ohio. But even in other areas that had wetter Marches and Aprils, conditions got really dry in May and certainly in June. What really kicked off last year's drought, in combination of those late spring dry conditions coming on, overall less, kind of a decreasing trend in precipitation if you look at the last 5 years. If you think about 2017, 2018, 2019 being very wet years in Ohio, we've trended down since then a bit. So we've lost over time a little bit more of that subsurface moisture. And so you combine that with the 9 to 10 day heat wave that brought above 90-degree temperatures for 9 or 10 days, like I said, and that really kickstarted this drought pretty rapidly. And so once we got into June, we were starting to see those pastures in Southeast Ohio really take a turn, and some of the progress and things. So, a lot of impacts last year. Many of you, I saw a lot of the names in the participant list, impacted by what we saw last year with tremendously, impacts on our water hauling, still happening in some of those locations in Southeast Ohio, although the springs are starting to come back quite a bit, and we'll talk about that later. But a lot of that water and farm water management becoming such a key impact last year as well. We saw a lot of those impacts on crops. This is Clifton Martin's picture from Muskingum. You would think that this was, harvest season in September, October, but this was soybeans about the third week of August. So, and then to follow that with, tremendous amount of fire risk and fire hazards that we saw last year. So, that would have also been plenty to deal with from a weather perspective, but Mother Nature had some other extremes and kind of things up her sleeve that even came along during the drought and then just at the end of the peak drought. And we'll get to that in a moment. So many of you have heard my talk before, but I always like to start with this idea with weather and climate because it's really important when we look at these changes over the long term, but even in the short term, trying to understand day-to-day weather variability that impacts our activities across the state. So this is what it looked like end of June last year in Greene County. And I think this time of year, a picture like this probably gives everyone goosebumps because you could feel the warmth and feel that warm breeze and really want to get out there and be out there and outside and enjoying this type of weather. We experience weather with our senses. And so this is how we experience it. As meteorologists, we look at it slightly different. A lot of figures, maps, data points, and we're making forecasts over longer periods of time. We're also collecting a lot of information over a long period of time, and that data can help us make some really strong decisions when it comes to things like, hey, should I plant soybeans or corn first? Or, what should I do in terms of applications and shrinking windows and things that Laura mentioned earlier as well. So how can we utilize that information? And that's really my ultimate goal, is just to provide some of that information. Sure why that isn't playing today. That's never happened before. So I'm going to skip that. So when, many of you, again, have seen me give the dog walker kind of talk before. And when we think about when we're out walking the dog, there's a lot of variability in the path that the dog takes, but we describe the mean path over time by the dog walker. And so, similarly, we can think about weather, right? We can have days, even in the month of February, like yesterday, when it hit 70 degrees in Ironton, down in southern Ohio, yet you can't forget just a couple of weeks ago with temperatures that were very cold across the region. And so thinking about how, it's going to be about average in terms of a temperature for the month of February in Ironton, even though their range was anywhere from the teens up to 70 degrees in the month of February. So a lot of variability there, and it's just kind of that example. So let's put that into context for droughts as well, and that variability with drought, to put last year into perspective. This is a map, a figure of the Palmer Drought Severity Index. This is a good index for long-term drought conditions. It was created in the mid-1960s. And this is looking or applying this index. It's based on precip, evaporation, and soil moisture model data back to the late 1800s. And everywhere you see the yellow or orange color, those are dry periods according to the Palmer drought. And then the green would be wet periods according to the Palmer drought. And again, it's looking at a long-term perspective of many months to a few years here. So if you look at that and you start breaking down this time series, a lot of variability, right? So Ohio experienced droughts, but we also experienced wet periods. But you can look at the data a little closer too. And if you look at that period of 1930s, 50s, 60s, that black brace that you see, these were years where Ohio experienced prolonged clusters of drought occurring over many months or multiple years, in fact. And since then, over the last 40 years, not only have we seen an increase in the amount of wetness across the region, so the wet peaks are higher according to the Palmer drought, so longer term wet periods, but the valleys or the bottom peaks for Palmer drought have not been as severe. They're lesser in magnitude than earlier in the record. So we don't see as intense of the long-term drought conditions, but that doesn't mean we don't see drought conditions as well. I think this is the pointer. Laser pointer. There we go. Right. We can think about 2011 still being the wettest year on record for Ohio, even though the Palmer drought was a little bit less wet as earlier in 1998 or 88. But you can see we followed that with the 2012 drought, right? So we get these rapid oscillations of drought conditions. And this year we were right around -4. So it was down there, certainly kind of rivaling 1999 and 99 and 88, but in 87 also, if you think about those 2 years. But overall, it's still less magnitude of what we saw in the 1930s, 50s, and 60s. And so the character of the drought has changed as well. I think by now a lot of you are familiar with the U.S. Drought Monitor map that's released every Thursday morning. The new one coming out this morning at 8:30 Eastern. That map attempts to do something a little different than the Palmer drought. So Palmer Drought Severity Index was used mostly for drought monitoring up until 2000. Since then, it's been a slightly different process. And the U.S. Drought Monitor map attempts to represent all different types of drought across different scales, short-term and long-term scales. We know, for instance, that drought can onset really rapidly during the summertime versus, say, the wintertime when those conditions move a lot more slowly. So thinking about that, the map attempts to add different types of drought: meteorological drought, agricultural drought. Agriculture is the first to be hit, often the hardest to see in terms of impacts during the growing season, but then also the hydrologic impacts from our reservoirs, our streams, our rivers. Ecological drought, we heard of a new ecological drought indicator last year, which is the number of muskrat traps remaining in the hardware stores in Northwest Ohio. So as the conditions get dry, muskrats move from those ditches that are now dry to the farm ponds, and you all are out there trying to find muskrat traps in order to take care of that problem. And that is an ecological drought indicator, which is pretty interesting of how that impacts our ecosystems and wildlife out there. And then, of course, the socioeconomic. So the big economic impact to farmers in Ohio last year, those numbers still being kind of finalized. And again, the approach now is sort of a hybrid approach, that we're not only using the physical indicators and indices, but we're not just relying on that data, the statistical data or the lack of precip, but it's really based on local expertise and impacts getting incorporated. Because drought in Ohio doesn't look like drought, say, in Colorado or Utah, right? And even though an index can give us similar numbers, drought might look very different, and those impacts are going to be different. So we really need a strong local influx of that information incorporated into the process. And we do have a drought team in Ohio. It's coordinated through the State Climate Office. My position is the state climatologist, but all of our National Weather Service offices that cover Ohio, we've got NOAA Eastern Regional Headquarters, our state agencies, really particularly Department of Ag and Emergency Management. We work with our surrounding state climate offices in Pennsylvania, West Virginia, Indiana, Kentucky, and Michigan, and then also university partners here at Ohio State, but also others like Ohio University and other universities here in the state. And what we're trying to do is converge all the evidence down to to get to across the different water cycle, um, to really get on a drought severity level. And so you'll see these on the map, yellow being abnormally dry, moderate drought conditions, unfortunately named, but that's our first drought conditions. Official drought is at D1 up to D4, which is exceptional drought. And when we look at exceptional drought conditions, those statistically should only happen about once every 50 to 100 years. So they don't happen very often. But again, impacts alone won't change the map. You need a combination of all these physical indicators and the impacts as well coming together. So let's use that framework. And again, I'll pause here in a few moments and take those questions. But when we look at last year and those categories, June 11th last year, we had no categories in drought. But things were getting really hot at this point. We were starting to heat up pretty quickly, and we had already put out the initial kind of indication through our drought response team that we could, depending on the forecast, move into drought pretty rapidly. By the end of June, we introduced D1. And again, I should say we have that local expertise team that adds information, but that's to a national author, a single author that's responsible for drawing the map that you see each week. And really the buck stops with them. And so they will take, the pressure and the heat of where those lines are drawn based on the conditions. But again, it is a robust process of pulling in local expertise and all of those indicators. But anyway, 2 weeks later, June 25th, we had some D1 introduced to Southwest Ohio, far Southeast, and then parts of Northeast Ohio as well. And then a couple of weeks later, July 16th, D2 was introduced. So severe drought across, say, Washington, Noble County, Guernsey County, Morgan County, those areas in southeastern Ohio, and also Pickaway County. A couple weeks later, though, and again, I don't, this radar image is working here. So we can see this, we had this outer band of Tropical Storm Debbie move in on August 8th. And this dropped a tremendous amount of rainfall from basically Orrville northeast up into Summit County, where anywhere from 4 to 8 inches of rain fell in some spots there. We had a little bit in central and southeast Ohio, but not much. But certainly, this area was in moderate drought conditions. And then you get all that rainfall over 5 or 6 hours. And these were types, the types of pictures that we were seeing. So big impacts again on these due to these extreme events. But that wasn't the last extreme that we were going to deal with in 2024. About a month later, August 13th, we had D3 or extreme drought introduced to Meigs County there in southeast Ohio. So this was the first D3 since August 28th of 2012, to give you a little indication of the type of drought conditions that we were experiencing. Western and Northeast conditions, again, had improved a bit over the course of the late July and early August, where rain was falling in those areas, but not in really central, south central, and southeastern Ohio. And then we get to the end of August, D4 was introduced, and this was the first time in the 24-year history of the Drought Monitor that we had D4 in the state. About a month later, September 24th, this is when we hit peak coverage across the state, so nearly 13% of the state in D4. And about 65%, 64% of the state in severe, extreme, or exceptional drought coverage. So quite the historical drought, certainly for Ohio. While it was dry early on in southeast Ohio, later on in the season, we started getting really dry across northwest Ohio, and even getting some D3 up there later in the season as well. So kind of in summary, if you look at the counties and a lot of the FSA programs, obviously, with automatically kicking in after a day of D3 or D4. You can look at the counties and how long they spent in those categories. So we had broad area of at least a week across much of southern and southeastern Ohio. A few counties there are 5 to 8 weeks, many more than 9 weeks, and then all of the purplish fuchsia color, those were more than 13 weeks spent with some portion of the county in D3 or D4. And then we can take that and we can look at the max percent in different production areas. So if you look at Ohio and you look at the production area based on the NASS reporting, about 27% of our corn production area was in D3 or D4, not necessarily just drought, but in D3, D4. So the worst of the drought conditions covered about a quarter of both our corn and soybean acreage areas. We can see our hay production areas of 45% in D3, D4. So the pastures and hay really hit hard, but they weren't alone. Obviously, we had impacts in our corn and soybeans as well. So I'll briefly go through, some of those impacts. 93% again of poor to very poor pasture conditions last year on September 23rd. So a lot of water hauling, a lot of winter feed being fed earlier in the season, and really needing those resources in terms of hauling water and getting additional livestock water as well. Impacts to our row crops. Generally, harvest activities began 2 to 3 weeks, and I know Laura and Osler are kind of talking about this 2024 season a bit. Very low late season soil moisture, not soil moisture, but crop moisture, leading to additional problems and elevated fire risks that we've already sort of hammered home. Some impacts on specialty crops, although it's a mixed bag. I was at the Wine and Grape Conference a couple of weeks ago, and folks were talking about really sweet wines and things from this year, and some sweet apples, and some other conversations that I've had with producers. But in Southeast Ohio, the conditions were not great. A loss of Christmas tree seedlings, for instance, across a large portion. A lot of creeks dry. Lowest river levels on the Hocking River, for instance. So a lot of, or one of the record lowest. We really go back to the 1930s to get lower levels on the Hocking River there south of Athens. Forest and fire impacts as well. I won't belabor these, and even landscapes that, as we get into this upcoming season, we'll learn of additional problems in terms of losses there as well. As I mentioned, we weren't done even with the drought because this monster came ashore in late September in the Big Bend region of Florida. This was Hurricane Helene. Really stretched out, interacted with a mid-level trough moving through the United States to really stretch that system northward into our region. About a day later, 24 to 36 hours later, we had the center, or I should say the northern central portion of the storm entering our southern counties here. So you can see the radar loop there on the left. Some severe weather associated with that, and very heavy rainfall, 5 to 10 inches from, say, Washington Courthouse down through Portsmouth. So extensive flooding across counties, as I mentioned, that were in D3, D4. And that's quite a challenge and quite a rapid oscillation between extremely dry to extremely wet conditions that really match some of the long-term trends that we're seeing and having to deal with from a production standpoint as well. Of course, that led to corn being knocked down. This is just an example there out at Western. And Laura and Taylor providing a lot of those photos of the soybean sprouting and the mold and things out there as well. So just a lot of extremes to deal with last year that really get us to where we are today, and we'll kind of update that from the winter conditions. But if you want some drought information, we continue to provide updates. The QR code is provided there. I would certainly say that drought of 2024 was one of Ohio's most impactful droughts. Officially, it started on June 27th and it officially ended on February 18th. So last week was the first week we were drought-free, according to the U.S. Drought Monitor, since June 27th. We experienced all types of droughts last year: meteorological, agricultural, hydrological, ecological, and socioeconomic. Ag and water resources have been challenged, but it depends on where you live. If you go to Eaton, Ohio, for instance, it was the third wettest year on record, sort of letting that out already, versus the driest conditions across eastern Ohio. And so, yes, robust conditions, but it certainly depends on where you were. We've got this drought early warning system across the Midwest called DEWS, Drought Early Warning System, and that works when you've got the coordinated efforts there. But it's also providing us an opportunity to kind of make our drought monitoring procedures even better for the state as well. So let me pause there before we move on and see if there are any questions Brian, I don't know if there's any questions in the
I don't see any questions in the Q&A at this moment, Aaron.
Okay. All right. Well, we will move forward then. Okay, so where are we? As we moved through the fall, we were forecasting La Nina conditions to develop across the region. So, kind of in just a real brief, what La Nina is, it's not a system or a storm, but it's a pattern that leads to increased trade winds, northeasterly trade winds in the North Pacific. You typically have colder water that upwells or comes up from the depths here on the western side of South America. And when you have increased trade winds, that colder water can then be pushed westward. And so most of the time, the warm water moves farther west, and you get this broad tongue of cooler than average sea surface temperatures in the tropical Pacific. And that changes our weather patterns across the globe. So if you look at areas here across North America, it tends to be warmer and dry across the southern tier of states of the United States in December through February when these events occur, and wetter conditions across the Ohio Valley. So we tend to have a very active jet stream that provides opportunities for rainfall across the region. And certainly as we got into November, December, we started to see a pattern take place, but it's been rather weak and inconsistent throughout the winter. So depending on where you are in the state, conditions in terms of improvements or continued drought conditions have fluctuated a bit over time. It also has impacts across South America. So, cooler conditions in parts of Brazil, wetter to the northern portions of South America. And then in June through August, even this past season, we talked about or we haven't talked about, but you've seen, dry conditions across parts of Argentina, really affected by this pattern. And so these are broad scale patterns that can give us those conditions, but things have to come together just right to see wetter conditions here in Ohio. So let's look over different time periods here over the last several weeks. So the last 7 days, this is our observed precipitation through this morning. So we had some decent rainfall across north central and northeast Ohio, less to the south and even less to the west as well. And as of yesterday morning, so it doesn't take into consideration our thunderstorms that moved through, some thunder and lightning overnight, which was, I don't know, it's always this time of year, kind of a shock to the system sometimes. Overall, the last 7 days have been drier than average, generally speaking. If we pull that back to the last 30 days, conditions have been pretty wet now. This La Nina pattern really, this is what it looks like, very wet across Kentucky and West Virginia and our southern counties in Ohio. But generally along and south and east of I-71, it's been above average. You can see that on the right-hand side, where we've seen anywhere from 3 upwards of 5 inches. Now, February is our driest month on average, right? So we typically only see about 2.5 inches of liquid equivalent precipitation during the month of February. So when you've got 4 or 5 inches, that you're certainly doubling your typical amount for February. But we have a lot of that dry conditions from our drought, that a lot of capacity to take on moisture here. And so we haven't seen extensive flooding. There's been some isolated flooding, and now we're starting to see some of that ponding in earnest across southwest and south central Ohio as well. But in northwest Ohio, conditions have been dry. We've had relatively very little snow. Most of the state is actually below average in terms of snowfall, although we had the one big system across the south back in January. But conditions have been dry, and reports are really consistent with that across northwest Ohio, at least in the last 30 days. You look at 60 days, again, some conflicting signals here. So it was wetter again in say late December, early January in Northwest Ohio, but drier over the recent period. And then you go back 90 days on the right-hand side. And again, we're looking at those two areas, Southeast and Northwest Ohio. And I think this picture of the 180 days, so the last 6 months of conditions here, we've got drier than normal conditions in northwest to southeast Ohio. So we've got elevated drought risk here. And what I want to point this out because it's really important for the upcoming season. It's very difficult to look and see what we think is prototypical drought in wintertime. But if you recall, for those that experienced the 1988 drought, That drought began, unlike this year, began in March. Things got dry in March and stayed dry March, April, May, and June. And that had a big agronomic impact of production and crops across the region. We also had 80s genetics and those things to go along with that. But it's really important to remember, and I think one big takeaway today is that, yeah, we have elevated drought risk from northwest to southeast Ohio. We may be out of drought for most of this region, but we've got to watch that really closely. And even going back a full year now, you see these spots, some areas of northwest Ohio, and then southeast Ohio, and even over in Mercer and Darke County, where we're below average for the last year. Going back to last February. And so we've got some deeper soil moisture deficits that are going to contribute to this elevated drought risk, depending on the forecast, right? And we'll get into the forecast here in a moment. Looking at our soil moisture ranking percentiles here, you can see that on the top left. Again, kind of stressing that area where we are at elevated risk for drought, depending on how the forecast plays out here over the next 2 to 3 months. Even though over the last month, you can see that soil moisture has increased, particularly across southern and southeastern Ohio. So while the sort of the epicenter has shifted and southeast Ohio is improving, there's still water. It's not perfect, right? There's still water hauling taking place. Springs are starting to come back because of this wetter conditions. We're focusing right now more on that northwest county area. And you can see that also in the figure on the right. This is more of a model ensemble, taking different information in to look at that key area across northwest Ohio being dry. So Indiana, Illinois, and northwest Ohio, as we head into the spring season, have elevated risk of drought in this region. Overall, our stream flows, let's just focus on the right-hand side because this is giving us a snapshot over the last 28 days. Lower stream flows than we historically expect this time of year. I think Vinayak, who's on and presenting in a little bit, talked about, kind of shared the fact that lines aren't really running here as much as we would expect even this time of the year. Even though we'll see what that forecast looks like here coming up. And then we still have some of that issue down in far southeast Jefferson County as well. But in our southern and central areas, our stream flows have really been restored to where we expect them this time of the year, mostly in the normal category. So even though we've been well above average in terms of precip, our rivers are just getting back to what we would expect here for late February. And that was basically because the soil is going to take it on as long as the soils aren't thawed, are going to take it on before we start to see that increased subsurface runoff across the region. So this is what it looked like across the country as winter began, according to the U.S. Drought Monitor here. So even as winter began, meteorologically speaking, we call that December 1st, we had large area of Ohio, and I'll zoom in here, but we had a large area really shifting drought conditions into the central plains and northern plains over the course of last fall. Even after Helene, October was the 7th driest October on record for Ohio. So, we still had dry conditions lingering well into the fall and a lot of drought conditions across much of the United States. And as winter ends, you can see there's not a major change in that. Again, it's moistened up in the mid-Atlantic and the southeastern Ohio region here. But we still have plenty of areas across Minnesota, Iowa, out into the Dakotas, Nebraska that are in moderate drought to even extreme drought conditions in the Midwest as well. So that's how we're starting our spring season as March is right around the corner. So a little closer view here, we began winter across Ohio with a large area of D1 or moderate drought conditions, and we still had counties in severe drought as conditions were improving. But over the course of the winter, we've now scaled back. And I mentioned officially our drought ended last week on February 18th. And then as of this morning, D1 conditions, moderate drought conditions, were reintroduced to northwest corner of Ohio. So we have Williams, a really small area of Fulton County and Defiance counties that are now in moderate drought conditions according to the U.S. Drought Monitor. So I suppose 2024 drought has ended, 2025 drought has begun, but we hope it's quite fleeting as conditions go here. Kind of the update on our La Nina conditions, that's what we were expecting, just to show what the sea surface temperatures compared to average look like right now in the tropical Pacific. And so these blue areas, we don't see as much of the cooler than normal temperatures here in the eastern Pacific that we would expect with a typical La Nina. We call these Central Pacific La Nina conditions, which again typically means weaker kind of pattern than we expect. And I think that's really consistent with the inconsistency that we've seen so far this winter. And we expect neutral conditions to really resume by the end of spring. Good 65% chance of seeing those neutral conditions and La Nina really fading out as we head into the next season, with the more likelihood of remaining neutral for the upcoming season as well. So no real strong signals from the tropical Pacific on what our summer really might look like here. So I'm sort of trapped. There we go. So what do we look like in the real short term here over the next several days? This is our surface analysis and what this looks like, the pattern that we have taking place. Again, we had those storms roll through last night. Some lightning, some thunder, some lightish rain, a little bit heavier in north central and northeast Ohio. Some lingering showers this morning as that system moves off to the east. We've got a change in the pattern here for tomorrow. We've got this Clipper system that's going to move through the Great Lakes, and it's going to kick up a tremendous amount of wind across our region here of Ohio. Warm conditions really prevail today and tomorrow, mostly in the 50s tomorrow. And then we've got to watch for some really strong winds here as well, 40 to 45 mile per hour winds from west central up into parts of Wood and Seneca and Wyandotte, this area up here. So could get close to 50 mile per hour winds tomorrow with this system moving through with this cold front, and then that sort of double feature cold front moving through. And this is what we get this time of year, right? Warm temperatures, cold temperatures. We're on this roller coaster now for a couple of months where we're back in the 20s and 30s this weekend. A little bit of snow across northeast Ohio as well. Overnight lows this weekend getting back into the teens and 20s for a couple days, but high pressure will move in here for Sunday and Monday. Before our next system, this is Tuesday now, conditions back up in the 50s for much of the state, southerly flow, and another pretty wet system, I think, moving in for midweek next week. So again, pushing highs close to 70 degrees along the Ohio River by midweek next week, but a little bit cooler across the north and a pretty strong windy, wet system moving in here for midweek next week. So again, this is typical of La Nina winters and what we see in during these La Nina conditions. But overall, we're looking at a good ½ inch to an inch of rain over the next 7 days, and this is a bit above average. As we get into March, we start seeing 1 inch per week is kind of average, or 3/4 to 1 inch. But right now, this is right at or a little bit above average. That first week of March, I think temperatures are leaning warmer than average. By the time we start March, we're seeing a lot of normals in the 40s. So I think we do see 50s and 60s during that first week. But that system midweek next week is indicating that period between March 4th and March 8th of seeing above average precipitation. So we've got some capacity to take on moisture, as I mentioned, because of those drought conditions, but we want to be really, watch it pretty close in terms of the upcoming season. So these are the latest outlooks from the Climate Prediction Center, which is part of NOAA, looking at really not a strong signal in terms of temperatures. The models, you've probably seen advertisement of another big polar vortex outbreak. These things are really hard to predict 2 and 3 weeks in advance. I think a lot of meteorologists do it because it's fun, or hobby meteorologists do it because it's fun, but it's not really looking like it's going to materialize. There will be ups and downs. There will be brief periods of cooler conditions, but that's pretty typical of March. But overall, we do expect March to be wetter than average for much of the Great Lakes and Tennessee, Ohio Valley region. And that's typical of La Nina. We get a very active storm track as that jet stream starts shifting back to the north, and that lingers then into March and even into the first part of April as well. So overall, if you look at what our, it's supposed to be, I didn't update. Overall, our ignore the January, February, March figure of the upper left. The March, April, May temperatures are leaning toward warmer than average overall, especially as we get into that April, May time period. So that's good in terms of our forecasts. but also wetter than average conditions are more likely than drier than average conditions or even near neutral conditions. So at some point, right, although we've got that elevated drought risk, and I hate to walk this kind of tightrope, but that's what we're doing. We could swing either way depending on the forecast, right? If we don't get the rainfall, I think drought risk is going to increase throughout the spring. And we could flash into drought a lot sooner or quicker without that increased rainfall. But if this comes to fruition the way we see it, I think we recover a lot of the soil moisture and overall have a good look at a decent spring planting season. We'll see what the windows look like. Obviously, with an active system, I would err on the side of not a lot of long dry periods, especially early March and April. In May, it gets a little bit more difficult to forecast this far out. So shorter periods, I think I say this every year, be ready to go when it's time to go, right? That's what you all do most of the years anyway. And then as we head into summer, again, I think that pattern, INSO neutral conditions, we sort of shift out of that pattern toward what we would expect equal chances of it being above normal or below normal in terms of rainfall, with probably slightly warmer than average temperatures throughout the summer as well. And that really goes back to some long-term trends in the forecast. So I think the big takeaways from the forecast, we still have elevated drought risk, Northwest and Southeast Ohio. If March is wet, then drought risk will decrease significantly. If March is dry, then I think we need to be prepared, right, for the drier conditions to maybe persist throughout the spring season. And especially as we get later on and into the early part of the summertime. So those are the takeaways that, from the forecast perspective. So I'll stop there for a second. I don't know if there are any questions, just chat stuff. Thanks for putting the links in there, Ryan. A lot of this stuff is good. Okay. So we've got a few more minutes. I know I started at 10 till, and I'm between you and lunch, I think, right? So I won't take up the rest of this time, but I want to put last year into perspective for the longer term stuff. And again, it's sort of updating what I've demonstrated before and shown before. But overall, if we look at last year, how does that compare? So we know last year, since 1850, it was the warmest year on record over that time frame for the globe. So the top 10 warmest years have all occurred in the last 10 years. It was also the warmest year on record back to 1895 for the United States. And you can see the rankings of the states there on the left-hand side. Most are in the top 5, and Ohio and many other states in that darkest red had their warmest year on record going back to 1895. So if we look at our temperatures compared to the annual mean there on the right-hand side, most of us were in that 2 to 4 degrees above average for the year, primarily driven by a very warm February and also a very warm November. And of course, last February, very different than this February, and that's that dog that walks back and forth on that annual basis. If we look at our individual cities where we have long-term records, some of these records for places like Dayton, Columbus, Cleveland, Toledo, Cincinnati go back to the 1880s. For these individual cities, it was their warmest year on record as well. So plenty of warmth. Relatively speaking, I think every month last year was above average for Ohio, and we can't say the same thing for this year because January was below average here across the state. Looking at the precip, we just talked about historical drought conditions in Ohio, yet it was only the 51st driest year on record if we go back to 1895. So there were 50 drier years over that course of time that were drier than this year, despite those drought conditions. And relatively speaking, we had a couple of pockets less than 75% of normal, but most areas were either what we would call close to average, close to the middle from a 30-year perspective. And again, I mentioned this earlier, Southeast Ohio, driest or top 5, top 10 driest cities there versus in Southwest Ohio, which ended up being, third wettest there in Preble County. Big differences across very short distances here in terms of precip. And that's what we can get with these extremes, particularly with precipitation. And last year's numbers really matched the trends that we've seen in terms of, we're increasing warmth across the country. But important for agriculture is that our winters and springs are getting warmer a lot faster than our summers. And as a matter of fact, some portions of the country are seeing cooler summers, especially in daytime highs. The overnight lows are getting warmer, but not necessarily the daytime highs. And along with that come changes in precip as well. Generally wetter since the early part of the 20th century, but I'll hone in on the last 50 years in just a moment. Just to kind of drive it home in terms of the seasonal changes, you can look at the trends in Ohio in terms of our winter trends increasing about 2.6 degrees over the 130-year record here. And if you look, 8 of the top 10 warmest winters have all occurred in the latter part of this record, 1990 on. With only two, actually our warmest year, still 1932-33, there, that very first peak, but only two before 1998 after 1990. So it's consistently warmer year after year in terms of winter, except this winter, of course, which we're at or slightly below average for December through February. Again, that's that dog moving back and forth, that chaos that you see on this photo. So our extremes are changing. We're not seeing as many hot days, which can be good from a production standpoint, but we're seeing fewer cold days in the winter and more warm nights as well. And of course, that has impacts that we've talked about quite a bit. We may not see as many 100-degree days, but we are seeing heat waves like last January generally increase. And we know that has big impacts on our biophysical functioning of our plants and animals. And those impacts may raise production inputs and reduce efficiencies in terms of production, nutritional value, and energy expenditure and things like that from a nutrition perspective. We're also changing the growing season length. And so, as we've defined it, right? So we've defined our last spring freeze to our first fall freeze as kind of the official growing season. We can look at different temperatures, whether that's 32 or 28. But most counties across Ohio are seeing statistically significant change in these growing seasons since 1950. Many of those darker color greens, this is anywhere from 21 to 35 days longer period between that first fall freeze, that last spring freeze and the first fall freeze. This is a great tool, and I would encourage anyone to check this out at the freeze date tool from the Midwestern Regional Climate Center. And you can look at your individual county and look, and there's a lot of maps that I'm not showing. One of the things I did want to show, this is from Wayne County, just as an example, looking at different temperatures along the horizontal axis, 20, 25, 28, and then the time goes from the top to the bottom. So March through July. When is that first time, the last time that we see this temperature in the spring, according, for the data for Wayne County? And you can see every one of these temperatures, whether it's 20 or 40, the last time we see those temperatures are occurring a lot earlier. So, we had quite a few periods where even like 36 was hit well into June in Wayne County, right? Not freezing conditions, but chilly conditions. And most of the time now, we don't see those after about the second week of May. And so you can look at each individual one here in Wayne County. It's about 6.3 days earlier where we see that last 32-degree temperature in the spring. You can do the same thing for your fall freeze temperatures and look at how those have changed over time. And for instance, 32 in Wayne County is about 10 and a half days later is when we see that first 32-degree temperature. And so that's where those growing season trends come from. But again, that's just temperature, right? You would think longer growing season, production windows getting wider. That's not the case because we see those changes in the precip, which are also seasonally dependent. Steph was talking a lot about, vomitoxin and some of the work with Pierce Paul and others, thinking about humidity and those thresholds that in humidity and how that may impact that disease. I think it's important to remember something that's kind of important in terms of humidity is we often talk about relative humidity. It's relative to a temperature. And so even though our temperatures are increasing, relative humidity globally trends are downward. And that's because temperatures are increasing. And so if you increase your temperature faster than you increase the amount of moisture in the atmosphere, relative humidity goes down, which you would think would decrease risk. The problem is it's not a real measure of the amount of moisture in the atmosphere. dew point temperature is. And what we've seen is an increase at regional scales of higher dew point temperatures, which means there's more moisture in the atmosphere. And so, that can kind of cause some, issues thinking about leaf wetness and diseases as well. We've seen an increase in the amount of moisture in the atmosphere, which is, part of the year pretty miserable, right? Um, in terms of those precip that I talked about, this year being a drought year, we still see drought years in an overall wetter environment. We've seen wetter conditions since the 70s overall, so more wet years, and even our drought years are wetter than most of the 20th century precipitation amounts. And you can see that in the left-hand side figure here. When we look at maps and how that changes since 1970, it's been getting wetter on the annual basis, but that's primarily driven by wetter winters. So this is January. So the greens representing 10-20% increase in January precipitation, increases in April on the order of, again, 10 to 20% across the state. And then in summertime, we're seeing flat to even negative trends or drier conditions in July and August, and then bring back wetter conditions for the fall. So these are some of the challenges that I think farmers are adapting to out in the fields today in terms of these seasonal changes in precip as well. And then any way we slice the intense precipitation events, those are changing over time. And I think I've shown, this quite a few times. The number of 1-inch events or greater is increasing as a proportion also of the total amount of precip we see per year. So we're seeing a lot of rainfall or heavier rainfall events in a handful of days across the year, which may not be great if we don't have really strong, water management implementation in place, which is really key and important. So our risk of extreme rainfall is increasing. This is what we call a 1 in 100 year rainfall events actually occurring across Western Ohio about once every 30 years, if you include the last 25 years of data. Our current products don't. NOAA Atlas 14 is a product that's utilized that shows these return periods that does not include that data. They're updating it. Protocol or officially September of 2026, but the initial results should be out September this year of adding that data and correcting those what we call precipitation curves. But we know that these 1 in 100 year events, what we call those, are occurring much more frequently across the region. So how do we build resilience to that in terms of an agro-production, agro-ecosystem way? We're expecting our temperatures to continue to increase, 3 to 5 degrees on average by mid-21st century with 10% more rainfall. We may not hit 100 degrees as often, but we do see increases in our 90-degree days on the order of 20 to 40 more days, mostly extending into the fall season. So more 90s in October, more 80s, perhaps 90s, hopefully not 90s in November, but we do see the potential for those increasing in the fall conditions, and then losing about 1 additional month of below freezing temperatures in our winter time. Getting really close here, want to stop, but in terms of kind of thinking about precip side, winter, springs, increasing in the amount of rainfall, increasing that precipitation with drier summers. This is what our models are showing us. So this is really consistent with our projections of both annual and seasonal runoff and soil moisture as well. And so if you look at the total annual runoff in any scenario into the future, it looks like we have more annual runoff, but mostly during winter and spring. So increases in winter and spring runoff, and lower flows, generally speaking, for our summer, right? And that's really consistent with what you see on the left-hand side, which is projected changes in average soil moisture between June and August. Much of Ohio and the Ohio Valley, showing drier soil moisture projected by mid-century here relative to what we've experienced between 1991 and 2020. So I think I had a few more slides to go into. I mean, just from an agronomic perspective, I think from a production perspective, I think what we've got to do is really think about adapting or continuing to think about how we adapt to a changing water cycle. We've had conservation practices in play for a really long time, whether, more recently kind of labeled some climate smart stuff, but what is climate smart? What isn't? We've got a lot of strategies, and thinking about those, how do we slow that progress of water from fields to streams. But more importantly, thinking about things that Vinayak's going to talk about in terms of irrigation efficiency, water management. These are key, I think, for Ohio. We get focused on temperatures, but really managing water is so key, and we take it for granted that we have it until we don't, like a year like this year, where we realize that if we can afford it and make those adjustments to our water management, we can build some resilience to these periods where we see either droughts or these seasonal water shortages that we expect to increase as we move into the future. We're going to continue to manage weeds, and continue to devote more resources there, because weeds love these conditions as well. Genetics play a huge role, right? And I've talked to a lot of farmers this year about, man, if we had 80s genetics this year, probably would have been a lot worse in terms of what we saw from a yield production standpoint. Soil health being at the heart of being able to withstand some of these extreme rainfall events, compaction and erosion being those kind of key factors as well. And then I would add also severe weather adaptation. It's really hard to forecast changes again in tornadoes or extreme wind events, but what we know is that the overall increases of an extreme weather are there. So how can we make infrastructure improvements that kind of shore up our buildings, our farms to those extreme winds, or be able to move that water efficiently? How can we protect that infrastructure as part of off-farm considerations from assets and emergency preparedness? These I think are also really good questions to ask. So I think the slides will be provided. There's a lot of resources out there, a couple from the USDA Midwest Climate Hub, Tree Atlas, and some additional information and projects as well. So take a look at those as your time allows. Certainly want to thank a lot of folks in Extension, Rob Hamilton with Soil and Water Conservation Districts, Morgan County, and others that have really helped us kind of provide kind of snapshots here of the drought conditions last year. And hopefully, we can get some of the soil moisture recovered here this spring and have a really good upcoming season heading into 2025. So I'll stop there and turn it back over to you, Ryan. Thanks.
Yeah, thanks, Aaron. If you do have questions for Aaron, as he's still on here, put him in that Q&A and he'll be able to answer them. Aaron, as you were talking, I think the take-home message I got for producers right now, if you're in those areas in Ohio that you were in that drought, be thankful for the rain that hopefully we're going to get here the next month. Do some equipment maintenance, do all the things to get ready, and be ready to roll when that window allows for us, because it is a roller coaster that we're expecting for weather, right?
Yeah, absolutely. And that may not be different, year to year, always being kind of prepared to roll when it's time. It's always a challenge matching the long-term changes in, say, production windows versus that year-to-year variability. And it becomes even more difficult when we're really can go either way, right? Toward
Yeah.
increased drought, or let's hope not, it gets so wet that we're delayed in the field again.
Yeah. Yeah.
So I think we've got a really slim margin between seeing either one of those scenarios this spring.
Yes. Yeah.
So we have to increase our ability to respond to highly variable conditions. I think that's another key of what we're doing here, season by season or even month by month.
Yeah. All right. Well, thank you very much, Aaron. I don't